Welcome everyone to the Friday of PyData Festival Amsterdam. So today is our last regular day of talks and workshops and everything along those lines. And I think we've got a really cool program again for you today. We'll start with this code breakfast by Alyona. I think Alyona will introduce herself at the start. During the lunch, we have another sprint preparation session and lightning talks as well. If you have something that you would like to talk for like 3 to 5 minutes about, can be anything, please sign up. It's always a lot of fun to hear what other people are up to. This evening, we have 3 additional talks. We have a talk about railway-oriented programming and a talk about making an impact with duct tape and how you can use artificial intelligence to monitor trees and forest fires and use it for social good. Please give a warm welcome to Alyona.
Okay, thanks. Hello, everyone. Wow, we have like 84 participants. It's awesome. So let's start. Now my screen is shared, so I do hope that you see everything. Just a second, I also got a message on Discord. Okay, so once again, hello, everyone. I would briefly cover what we're going to discuss in the workshop. But before introducing myself and starting, I want to point to some really important stuff at the GitHub repo. So if you just join, if you just clone it and want to follow along, maybe it will be not possible because you need to download at least 8 gigabytes of data and the weight from release pages. Also, what I noticed, if you're working on Linux or Mac, you can follow along. If you're on Windows and don't using VSL, Windows subsystem of Linux, then we need to do some changes. Okay, so let me. And I try to give all instruction as neat as possible in the README file. Just make sure that you follow the steps. Okay, so let's start. Yeah, the title of this workshop is Human-like Visual Search Application with Small Data. Sounds cool. So let's see what it will be. So the workshop materials, this is a link to GitHub repo, or you can pick it up from Discord channel. Read README file and install everything from environment YAML. Okay, so this is our workshop structure. So the first will be brief introduction. Who am I? Why I'm here to talk to you? Then we'll discover briefly the building blocks of Siamese Mask R-CNN. Then we'll discuss Siamese Mask R-CNN single deployment with Fast API. And what is the link to this material? The link is in a GitHub repo and as well in Discord channel. This is what I see. Okay. Then known limitation and possible improvements. Okay, so introductions. First, about me. Who am I? My name is Alyona Galyeva. Currently, I'm working as a principal data solutions engineer at Linkit with emphasis on productionizing machine learning. And as I always joking, during the day, I have a full-time job. During the night, I work for PyLadies, but it's just a joke. So, and I'm one of 2 co-organizers of PyLadies Amsterdam. And I would briefly tell you about what it is. So PyLadies Amsterdam, it's a local chapter of a global nonprofit PyLadies. And last November, our chapter was officially recognized by Python Software Foundation, so we're really proud about it. And each chapter has its own freedom what to do, and with only one concern that at least 95% of the activities should be dedicated to Python, of course. So what we do as a PyLadies Amsterdam, we are doing coding workshops on a monthly basis. And later we even had a boot camp. So how it looks like. So before the COVID situation, it looks like this. This is the situation after the workshop. We even have Naomi, the former chair of Python Software Foundation, that joined by coincidence one of our workshops. Yeah, like happy people. I hope you see those pictures. This is how the settings looks like when you do the coding part. And after February, so this was actually the last offline workshop, and this is how we decided to continue further with online workshops. Okay, so feel free to contact me via LinkedIn or any other channel. I think, as I mentioned before, we have these built-in blocks. And between those blocks, we can take some time for Q&A. And then, as well, as you know, after this session, you will have an aftercare time when you ask all your questions on Discord, and I will be happy to answer it here. So let me briefly check, after the introduction, let me briefly check the Q&A, and then we'll follow. Okay. I see the question from Thomas Handke. I'm trying to run the repo. I missed the end file with the relative path. Could you please share a copy? Let me briefly check. 1 second. Actually, it should be in the root folder. And, oh, okay.
Your git ignore.
Yes, my git ignore, yeah. What the best option? Should I push it right? Okay, I think I can just really fast push it. Yeah, okay. Sorry, my bad. It goes automatically. Yeah. Yep. That. Yes. And for those who wants to have some time and get a cup of coffee, you have a time for it for now, at least for 2 minutes, I think. Okay, 1 second. I'm merging it with master right now. Yes, so please refresh the repo and you will get access to it. Yes, now it's here. Okay, anything else? What I see? Yeah, the link to material. Okay, so we covered. I think we're ready to go for the next one. Okay, so before, let's briefly recap what is common computer vision tasks. So I assume a lot of you have seen this picture before. So when we're talking about computer vision, we are talking mostly about classification, object detection, semantic segmentation, or instance segmentation, or even more. So if we are talking about classification, is briefly, we are looking at the picture and we're saying if there is an object, if it's present or not. Or it's like, that's it, I think, the basic thing. The object detection takes the next step forward. And object detection say to us, first, check if the object is on the picture, and then if we can locate where this object is on the picture. So basically, we are talking about the, we call them bounding boxes. It's just the x, y coordinates where an object is located. So yeah, sounds not so complicated for now. Then we have the segmentation. What is segmentation? When we're talking about segmentation, it's pixel-wise classification. So in this case, we should say that each pixel from this balloon belongs here, and this pixel doesn't belong to these balloons. But the semantic segmentation is a little bit limited because it treats all these objects as one thing. And now we finally went to the instance segmentation, and it's really interesting concept. So you don't only have the pixel-wise classification and you know that each pixel belongs to each object, you know exactly to which object this pixel belongs. So now you see that we have this as, let's say, like bounding boxes where the balloons are located. We can count these balloons, and we know that all these balloons are separate instances. So it sounds really, really cool, right? So why I'm talking about this? Because original idea of the app, of the visual search, will be using the instance segmentation. Although we need to mention the Siamese network as well. So the first time when I came across the Siamese network was, oh, by the way, it was at the joint event of PyData Amsterdam and PyData Amsterdam. So we have NLP talks. And so far as I remember, the last person was presented, it was from text kernel, and this person actually present the thing how they use Siamese network to find the similarities in job vacancies in different languages. So if we are talking about Siamese neural networks for computer vision, so we have, let's say, two pictures, two images that we want to compare, and we put these images, let's say, through the convolutional neural network, then we get, let's say, two big vectors, and we just compare the distance between these vectors, and let's say, okay, is it looks like similar or not? Why do we need this? If we want to search for something, and if we are trying to search something with a picture and we try to find another picture, it's really nice to understand whether these pictures are similar or not. And then, because the model that we are going to use, it's Siamese. It uses Siamese neural network. It uses instance segmentation. And on top of it, it uses one-shot instance segmentation. So what is one-shot segmentation? There is a cool concept that is called meta-learning. And if we look at it, so we can talk about zero-shot, one-shot, or few shots learning. In this case, we are working with Siamese architecture again. In the first case, with the zero-shot, what we actually give, we give not an image, but we give text that describes something. And we have an image, and we compare these two branches, like image and text, to find whether it belongs to or not. If we're talking about one shot, so actually we're trying to have one picture and then compare it with another picture. And if we have the few shot, then we know that at least our model have seen, at least depends on the number of pictures, we define the number of shots, and we say whether it's one shot, two shot, three shot, depends on the number of the pictures. So this is really, really brief recap. So yeah, we will be talking about Siamese Mask R-CNN. So this is the neural network that was originally built on ResNet. Then we have, on top of ResNet, we have all these layers that do its job, and we have Mask R-CNN, and then the Siamese architecture was added to that to perform the tasks. So, okay, let's go further. So, once again, if you clone the repo, if you just clone the repo, it will take some time for you, because you need to download at least 8 gigabytes of data. It will be done. You can start downloading them, by the way, because it's done by script. Also, if you're doing it on Linux or Mac, it will work. If you're going to do it on pure Windows, there is an issue. The source code of the libraries has some hard-coded path, and these hard-coded paths are Linux-oriented. So this is the issue with Windows. So if you have Windows, sorry, only one option to use it as I'm using right now. So I run in this workshop on Windows 10, but on actually on Ubuntu, on Linux, on VSL. So for Windows people, I think we can get back to it later, because I can rearrange the workshop for Windows, but we need to rewrite a lot of source codes of these two models to get rid of it. Okay, so let's start and cover the building blocks of Mask Siamese R-CNN. So we came to this inevitable step to download all required libraries. This is, let's say, the most tedious part, but we need to have it. I should say that's not the best practice as well to use to take the environment variables here. So we can discuss later how it can be improved. But now, before diving in, I have one task for all of you. So my repo currently is missing one really mission critical folder. So think about it, which folder is missing or what should be placed in this folder, and let's get back to it at the end of our workshop. I'm really curious to see all your replies. What kind of folder with what kind of, I don't know, pieces of code or maybe something else is missing here. So, okay, first make sure that you're in a conda environment. When you work on VSL, you need to check it in some places. Just let me have a sanity check this way. Yes, so this is, we are here, I have conda, and we are here. Okay, so let me run first to download all the libraries. And actually what's happening there, first we're using .env. That's the file that was missing. My bad, sorry, because usually you don't share such information on GitHub repos. So then you download basic libraries, and then the rest of it, this are the source code. This is the source code for Mask R-CNN, and this is the source code for the CMS Mask R-CNN. And as well, syspass append, trust me, it's not the best practice to do, so we can discuss how it can be improved later. Okay, so now the model we are going to use, it's already pre-trained. Why? Because it's really, really heavy. So now I have two configurations for this model. One configuration is approximately like, it takes 1 week to train on 4 GPUs. And if you try to train the small config, although it's transfer learning, so you're not training it from scratch, it requires approximately like 4 or 5 days. So that's why in this workshop, we are going to use these pre-trained models. And I know that not everybody has an access to GPU on the laptops. That's why this model can run on CPU. I mean, the predictions, the inference part can run on CPU. And actually, it uses still, let's say, all types of libraries. So it still uses TensorFlow 1.13. And it was the time when if you want to run TensorFlow on GPU and TensorFlow on CPU, you need to install 2 complete different packages for TensorFlow. It seems to me that only after 1.16, they now merge it into one. So in this case, even this code says, let's say it's run on GPU, it runs on CPU as well. So it's okay to know. So first, I just loaded all the libraries. And then before diving to the model, let's briefly recap what is MSCOCO. So this model was originally trained on the MSCOCO dataset. And actually, it's a large-scale object dictation, segmentation, captioning dataset. It has a lot of annotations, a lot of images. So yeah, the decision to train this model on this particular data set, I think, was actually because of all the annotations that were available for it. Yeah, but we'll see. And for this particular use case, for the for Siamese Mask R-CNN, this data set was processed in a very specific way. And actually, let me first run this cell. Yes, they define one-shot classes. So we have, for a data set, we have 80 categories for MSCOCO, 80 categories. And based on this formula, they actually choose some categories for one-shot classes to perform one-shot instance segmentation later. Okay, so this is our data set, as I mentioned. And as I said before, we need to download it. So the scripts that is in data utilities folder let you to download train and validation sorry, not train, validation and test set. So that's what I mentioned. It was approximately 8 gigabytes. It will take 8 gigabytes of space. In the future, if you want to play with this model further, I advise you, I have a link to the original repo with the source code. So go and download the original the training set, but it will take approximately like 30 gigabytes of space. But for the purpose of this workshop, we downloaded only 8. Now I have the data set downloaded on my local machine. So in this case, I just run some preparations to load the subset of it, in this case, this validation, to prepare, to build some indices, to know where to look for, and to activate one-shot classes. Okay, so now let's take a look at the model. So this is the original model that was used as a base. This is a Mask R-CNN model. And actually what this model does, I want to briefly cover its components. So we have backbone. Think of a backbone as a feature extractor. And this backbone, it can be ResNet 50 or ResNet 101. So this is our feature extractor. So we have different layers. The first layers extract the low-level features such as ages, corners, think rates, and then it goes to the more high-level features like person, sky. So after that, when we have our features extracted, we pre-process them as well with feature permit network. And what's interesting with this model, it has actually 2. That's why it works and performs better. So it's actually like, it improves the whole feature extraction process as well. And then we are going to the HATS part. So what's happening here? Here we have RPN. RPN stands for Region Proposal Network. So this is really lightweight neural network. What it's actually doing? So it scans the whole image in a sliding window fashion and finds all areas that contain object of our interest. And what we do, we perform like this scan. We call them anchors. So actually, each picture can has a lot of this anchors, more like than 200K anchors, wherever, different on the size of the images and what we are doing. And yeah, if you do it on GPU, it's pretty fast. If you do it on a CPU, it's slower. But this is what you get from it. And then I forgot to mention that when you working with RPN, what we have here, so we get the anchor class, and usually it works, it has 2 classes. It has a class that say, okay, this object is on background, and this is the object in the foreground. And it creates the bounding boxes and try to say, okay, try to refine these bounding boxes at the end to say, so there is like the high probability that something is in it. Let's refine it to these bounding boxes. And then only after that, we go through the ROI classifier. We pick up only regions of interest, and then we process it further. We do some pooling, because for classifiers, it's really hard to understand if all inputs is not very well sized. So, and then let's say the last step for us with this model, this is to create the segmentation mask. And this is really, and this is really, let's say, tedious task to create them. So yeah, this is the backbone of, this is the Mask R-CNN model. And now let's take a look at the architecture of Siamese Mask R-CNN. And as I mentioned before, they're really heavy models. So yeah, this is Mask R-CNN. If you see the difference between these 2 models, this is actually the Siamese backbone that was added here. So it looks almost like the same, the heads part. Here we have backbone with ResNet, and here we have Siamese backbone. So in this case, we have one image or batch of images as an input, and we get some predictions and mask at the end. And with Siamese, we have a reference image, an image. We do feature extraction and feature matching. And if there is a match, then we proceed further with heads. So I think it's enough of theory. It was too much. So for this option, we can talk about different configurations I mentioned before. So we have small configuration and we have large configuration, the difference in the way how they were trained. But for both of them, we have pre-trained weights. That's why I say, so if you want to play along with inference, don't forget to download them from release. And if you want to train this model further as well, so we have the small configuration and large one. Let me start. Okay, it's done. And then let's pick a model size. Okay, let's start with the small one for now. Okay, I just run the configuration. So now it says, if we say config display, remember that here for the small evaluation config, we say, okay, this is GPU, images per GPU, the basic information. And here, when we ask to display the config, we see the backbone ResNet 50 and the rest of the parameters. What I also worth mentioning, that the whole approach to train this model was, we know that ResNet usually trains on ImageNet dataset. So the people who wrote this paper and who proposed this model, they actually go through ImageNet datasets and they remove the categories that that MS-CoC already has in order to not to have, let's say, the same categories twice. So this, we download the config of our model, then it just picks the checkpoints to download weights, and that's what I mentioned. Yeah, this hard-coded path. And you see that it's applicable for Linux or Mac, but not applicable for basic Windows. Okay, so now the first part was, it's a really brief introduction about what the model does, what the peculiarities, how it performs. And your home assignment will be to investigate the original article, the source codes and lib folder, and think over what can be improved and optimized for better performance. What I also forget to mention about this one, really important part about this. So when we do this matching, remember, so we have features, and when we do this matching, let's say we just measure the distance between them, and if it's okay, we pass it further to RPN, and if it's not, then sometimes we're stopping. Okay, so this is that for that part. It was really brief. I think now we have, let's say, 1, 2, 4 minutes. If you have any questions regarding this part, and then we move further for the deployment. Okay, I'm just reading in the meantime, yeah, the Zoom webinar chart. Okay. For now, I don't see anything incoming, so I can assume that we can move forward.
A question just popped up. So the idea of the Siamese network is that both networks are identical, right? It's a question by Dennis Buckhouse.
Yeah, just a sec. Yeah, so the idea seems that both networks are identical, right? Yeah, they're different as well. If we go in depth into the Siamese architecture, there is some stuff that's called, it's not mirrored Siamese network. So the idea, let's say they should be identical, but there are different configuration of it as well. So, in this case, we assume in this that they are identical in this case. Yeah. Okay. Okay. So I think we can go further if there are no questions. Or, oh no, I see something popping up. Okay. So I ran conda and creative environment YAML, but after resolving conflicts, the app environment doesn't show up. Conda environment list. Good question. First of all, it can be another. If you do conda and fleeced, I'm wondering what kind of environment you get. Maybe just get another name. If not, I think we need to check the configuration of conda. I don't know what you're using. You using bash, zish, or what kind of terminal do you use? I remember that Thomas mentioned that he works on Mac, so I assume maybe zish or bash.
Bash on Mac.
Bash on Mac. Bash on Mac. Okay. Frankly speaking, I don't remember from my head all the comments to configure conda.
Maybe this is good for the aftercare to really dive into.
Yeah, I think this is a great one. Okay, Thomas, if it's okay, then I think we can move forward for this. Then the question from Grima, so why keep two networks? It's a really good question. So actually, it's not two networks. It's one network. I will go back for a second. It's a really good question. Thank you. So in this case, what we have image. Then we constructed features. We extracted features from this image. And then we continue further with this. In case with Siamese, we want to compare to why we're doing this. If we want in the future use Mask R-CNN, we cannot just apply any and retrain it on a new data set. It's not possible just add any images without any pre-processing, without any extra annotation, masks, and it's really tedious tasks. Actually, I think personally that one-shot learning or zero-shot or few-shot learning try to solve this problem. We call this small data. Because, okay, now you have this large data sets, but what if you want to fine-tune your network for particular use case? And then you need, even although you're using transfer learning, you take the part of Mask R-CNN, you remove the last layer, the classifier, or some layers. It depends on how deep you want to have. Not how deep. Sorry. So in the transfer learning, you still need a lot of images. That's what I'm trying to say. If you're using Siamese network, it try for you to reduce this overhead, and it's saying so. What we're trying to do, based on only some of the images, so not hundreds of thousands of millions, based on 2, 3, 5, 6 images. When the model sees this particular object once, we give a task to this model to find this object on the rest of the images. So that's, I think, the light version of explanation, why to keep two. Personally, what I noticed, I can say that I'm a little bit biased towards maybe engineering part. So for me, this model, the Siamese Mask R-CNN model, is really computationally expensive, and regarding inference is well really computationally expensive. So I'd rather use first separate Siamese Mask Siamese neural network, let's say like the first model that will filter stuff for me and say, okay, if there is, I have 2 incoming images, if they're match, then push them downstream to process by another lightweight neural network to classify them further or do the magic. And in this case, it's one model. That's why it runs, although trained, it still runs really, really slow. But that's something that it's not possible to solve by one neural network, and we try to use different or combine them as a, let's say, combo to get the best results. So I think now I can continue. If there are any, let's say, questions about this part, please talk to me after. I will be there with you in the Discord channel, and we can discuss actually, do we need this or not? Is it the best approach or not? But for now, for this particular task, this is the article from 2019. I checked also the latest articles, research papers from 2020. We have if I'm not mistaken, the name of the Facebook algorithm is Detectron. So they also advertise it as an algorithm that can do everything, and classification, object segmentation, semantic segmentation. So a lot of stuff in one. I didn't try it yet, so I don't know what to expect from it. So let's see. Okay. So now let's move to the second part. And idea was to create a visual search app. So how I envisioned this search app. Imagine I have an image, and based on this image, I want to find the similar one. That's why we're saying like visual search. So, and this can be done only by using Siamese neural network in this case. So actually, we will transform images or videos, depends on what we want to do, and then compare them. And if there is, let's say, if there is a match, then we say, okay, maybe this picture looks like this. In case with, if you want to get something more out of it, not just say, okay, these two images are identical or looks like or look similar, but if you want to go for a next step and identify what exactly located on this image, as a use case, think over e-commerce, for example. Recommendation system based on, or it can be, I don't know, any like, how we call it, web shops. So you say, okay, I'm looking for this particular article, and I got the recommendation of the articles that looks like this. Okay, maybe in this case, the Siamese neural network will do its job. But if we want to have something more, if we want to get not just, okay, it looks similar, but I know that the thing that you're looking for at this image, we have at this image as well, where particularly in this image we have it, what are the boundaries of it? And even to identify each, let's say, each items, it's completely different story. And for now, we don't have this unique engine that do it. So that's why we try and, let's say, to prototype something. And for this, I decided to use the Siamese Mask R-CNN, although it's slow for now, because it can give us at least a possibility to look into the future. So when we are talking about deployment, what I want to emphasize, so the model that we have, it's not the end product, right? So this model lives in the world, and it's surrounded by a lot of things, and it should interact with a lot of pieces. So when I thinking about the machine learning models, I always thinking in them in the case of the pipeline. So we always have some data incoming, then we need to understand that the data are correct. So in our case, if it's a video stream or it's just images, we need to be sure that it's images and not something else, and that we pre-process these images, we resize them, reshape them, and make them digestible for the model. Then we train the model. Then we spend a lot on model tuning, and there are a lot of useful tools on the market available for it. And then we analyze the model, we validate it, and only after that we say, okay, maybe now it's time to try to deploy this model first to the dev, and then further to the stage and maybe to production in the future. And also we need to find a way how to collect the feedback. So in this case, if we are talking about our model, and if we want to build this visual search thing, so we need to think first, okay, so we will have incoming images or videos, then we need to process these images. We have already our pre-trained model, so now we're using two configurations, small and big one. Okay, what's the next step? And here there's a thing I just decided to show this table. This is CPU, we see GPU deployment. This is the question that I always asked. So what should we do? Should we use this or this? As I mentioned, if the model is really heavy, maybe we can use the GPU. But then the question is, what are the costs of using it? And if we're just doing some fun app for ourselves, it will be really, really costly. So what to do, CPU or GPU? that's hard questions that you always ask. This is just comparison of throughput image per second. From this side, we have image per second. From this side, we have different biggest models and the frameworks. And then we have comparison. The blue thing, it's a CPU. This is the blue one, you see, the performance of it. And red one, this is when we use 3 GPU. And as I mentioned before, this model was trained on four CPUs. So let's check what's the idea of visual search, how it looks like. First, we will initialize our model in inference mode and load checkpoints to use it. So it can take some time for initialization. Okay, so let's say we're loading checkpoints, so we're starting from epoch 160. And then we say we have different categories that we can change. And we have our target image. This is the smallest image. And then we have our another image. In this case, target image is pre-processed, and it contains masks, it contains bounding boxes and all annotations. And in case with the image that we try to compare to, it has only basic annotations, but it doesn't have masks, anything. So the idea is with this small target image to see what we can extract from this big image. So let me run this just to show you what will be there. Yeah, it can take some time, as I mentioned. Let's take a look at the results. Yeah, so you see this is not the best one. So the target image is really small. Even for me, it's hard to identify. It looks like it's a emu or a bird. And it's actually tried to identify the bird in the cage and say, okay, I'm pretty sure that this is something birdish-like. And then somehow it picks up the screen and the person as well, something that looks like maybe a bird on the background. So still you see without all this fine-tuning, and this is let's say the paper with a lot of errors, and it's still you see the models performs really, really strange. Okay, here we have the pigeon as a reference. And although we have only pigeon, this picture doesn't contain pigeon, but it picks up the bird, so it's a good one. It says, okay, I almost 100% sure that that's what I'm looking for. The shape look like this, so it's a bird. And then it still picks up their stuff. The biggest issue with visual search in real life, if you want to perform it, normally you do it in really, let's say, cluttered settings. Because if you look back at the, let's say, basic data sets, you have something on the foreground, really big one, almost always in the center. And then you say, okay, my model performs great. It identifies. But in real life case, you have a lot of things on the background. So yeah, and this is the really hard. So the idea of our app, let's say, of our application will be that we give it just a random image, and we say compare it with a target. And if you see the similarity, map on my image all these objects, identify these objects as a separate objects, draw the bounding box, and apply the mask, the segmentation mask. This is the original idea. Okay, so now let's start building our first API with Fast API. Regarding deployment, I also want to note, I'm talking now about single deployments. What do I mean by that? This is the first time we deploy only one model. That's it. It can be all other options will not cover it here. There are a lot of pros and cons. Which framework to choose to deploy the models, how to do it. It depends on the models. It depends on the incoming data. It's a lot of moving pieces in it. So usually, if you look at the internet, there are different tutorials that are talking about like, build a Flask app, only 2 lines of code and you're ready to go. Unfortunately, in real life, with a Flask app, it doesn't work this way because even when you do some stuff with, let's say, Flask, and if you're not using the servers, Yeah. Or you can go with a TensorFlow serving if you have like TensorFlow compatible models, or convert your models to TensorFlow compatible format. You have different cloud options of deploying your model. We have the SageMaker that can do a lot of stuff for us. We have AutoML. And then we have as well such things like a Seldom. If you're working with Kubernetes, that there is a possibility to deploy model, scale, descale really fast. But for the sake of this workshop, we'll be doing some magic with Fast API. I heard that actually there was a session on Monday regarding Fast API. So I'm really looking forward to rewatching the record of this video. And why Fast API? It looks really neat. It looks really nice. So yeah, let's start, and I will show you actually why the Fast API. Okay, so for now, let me open the main.py. First, we briefly cover the code, and then to see what it can give us. So once again, it's not a production level thing in this case. The code is not optimized. It has a lot of hard-coded stuff. And usually when you create an API, you create the structure because you want to separate concerns. You don't want to have one file that do everything for you. In our case, we're using two files. It's main.py file that will run our Fast API app. And as well, we are using another, it calls settings.py. So usually when you configure your API, you have some variables or secrets that you want to keep. You don't want to expose them to people. There are different ways how you can do it. So in this case, I need a path to uptest data, to the COCO dataset, to the Mask R-CNN model path. This is because of all hard-coded dependencies in the source code, and the model directory when we have all logs for our model directory. Maybe I'm jumping. Sorry if I jump too fast between the components. If something unclear, please ask, or let's discuss it after in the Discord. So if we are talking about prototyping something, we want to have, let's say, something that do its job. And if we're talking about an app, so yeah, we can always ask somebody or build the simple front end for us. But before doing this, we need to understand how we can input data and output data from it. So in this case, if we want to do this, we want to say, okay, I want to upload my image. And then based on the image, I want to get the results. So to get something that looks like this. So I upload the image, it compares with a target image, and it gives me back something. And usually what we are doing, we found some way how we want to communicate with our model. And we need to find a way how we can send data to our model and how we can get data back from our model. So in this case, that's why we're building this API. So let's briefly check what is here. So once again, we load in the basic libraries. Then we load the Fast API related libraries with some extensions, with the possibility to upload files. And as well, what I really love in this case, so under hood, it uses PyData, and actually it allows you to validate your data. So remember, garbage in, garbage out. In this case, it doesn't allow a lot of garbage to come in when doing all these calls. Then we import the stuff to get the environment up and running. And this, once again, this turbo hack to make it running because of all the hard-coded dependencies in the source code of both libraries. And here what we're doing, we actually define our request body. So we can have different options before sending images, whatever I wanted to try to send something like to pick up a category number. So let's say the first step, I know that for now, if we are working with a mass COCO data set, we index all images, and we know that some of the images belongs to different categories. So the first call that I want to try to do, I send, what if I can send the number of the category and let the model randomly pick up target image, compare them, and return results if there was some findings, there was something similar. And for this, I define just the incoming request. This is our request body, and I say it should be a number, because in our case, category, it's a number, it's an integer. And then we can as well define for all other requests the format, and as well we can define the format here. So it works like a error catching. It's double checking your input and output. Then this class was defined just to decode the arrays to the JSON format. And then what we have here, we have our small evaluation config. We have large evaluation config file, so we can work with two types of the models in inference mode. And then the code for now, we need to load model. I want to point out one thing, what I really often see in the code. So the people try to load the model, not in the very beginning, but they try to load model with each request. And I want to point out that it's highly inefficient, because imagine is every time you send a request, you load your model again. And if you have a big model, and if it takes a lot of time, then what you get. I just saw the answer I'm getting here. Config app test data is missing, has no default when running main.py. And this is the question from Sebastian. To get rid of this thing, you need to first make sure that you have .env file, because I added it in the morning to the repo. So you need to make sure that this .env file in place. And if you want to run this main.py file, you need to run it from the workshop root folder. So we'll come to this part. That's why it's saying it's missing, because it's called the settings, and settings reading our environment variables from .env. And if you don't have them in place, that's why it complains that it's impossible to run it. Okay, let me get back. Okay. So for this now, we are loading model. So I stop the place where we loading model. So we can pick up a small or big size. It gives a configuration and use a checkpoint to download the weights. Then we initialize our model. And we need as well to have a graph. If we don't use the graph here, then we will got a really nasty error, especially from the oldest version of TensorFlow, because each time it will try to recreate the graph, it's really computationally expensive as well. So we load model, and our model return the model and graph to us. Okay, Sebastian say that's edit environment file things. Yeah, it's important. Normally, when you will be working, it will be up to you to decide how you or your company manages the secrets, manages all environment variables. Usually have the set of different YAML files or .env files where you put all necessary environmental variables, and the rest of it, think over if you want to deploy an app. Now we're doing the really, really basic version of it. So what we're doing, we say, okay, spin up, load the model, send a number, or upload an image, send an image there, preprocess it, send it there, and get back some reply from the model in JSON format, definitely. And then, okay, I see as well the one question. One person raised the hand. Okay. Two person raised the hands. Okay, I think if you raise the hands, maybe if you want to stop me, okay, let me know. It will be really helpful if you send it as a question. I think maybe then I can understand how can I help you. So please, these two people who raised the hand, please send the questions. Or if you want, if it can wait, we can discuss it later in the aftercare session at Discord. It's up to you. Okay. So as I mentioned before, we load in our model, then we prepare in our data set to index it. Once again, maybe we can do all the preparations before. It shouldn't be in one app, but for the sake of this demo, we're doing this. Then we need to some prepare reshaping the image, and then we initialize our FAST API. Actually, the whole concept of FAST API really looks similar to Flask. So if you have experience with Flask before, it's really easy to switch. So we initialize the up. In the beginning, we say the model is none, then we replace it. And we load our model, we load our graph. Just for here, I added the basic sys argument just to pick up which size of the model we want to load. Then we prepare data sets. Okay, and then we define. So it looks, once again, we use decorators. It looks like the Flask. What's the difference here? We can immediately define the format, what you want to do. You want to get, or you want to post something, or you want put or delete. So we say app get, and then we'll see how it works in a second. And then you can define the rest. In this case, it's a post method. What this post method is doing, it's saying, I want to pick up the category in the range from 1 to 80. And based on this category, I will randomly pick up, and let's say the big image that doesn't have any masks or annotations. And then I want to pick up the target image, like the small image that has masks, all annotations attached to it. And then I will ask the model to check these two images and return back to me the results and say to me in the JSON format, okay, so what we get from it, we want to see all regions of interest. We want to see all the masks there are a lot of masks. Then we want to see the class ADIs and the scores that we get. And we return the JSON results. And then as well, this is the really simple one, just to like a sanity check to see what's happening there. And then we have, let's say we're trying to predict the image. So actually what we do, we upload a file. We read this, we upload this file, we read this file, we pre-process it, we resize it based on the necessities. We add only one image, it's the big one, and we'll compare it with the target one. And as well, we run the predictions. Normally on all FAST API tutorials, you don't need to use if name main, you don't need to use this part, and you don't need to import the UVcorn on top. What you can do, you can just use a command UVcorn app reload, and it will spin up a UVcorn server for you. But for now, I do this only in the sake of, let's say, the possibility to choose the size of the model. Okay, so for now, let's say we want to run it and we want to have the small one. And while we'll be running this file, I want to show you what's the, let's say, the added value of FAST API. So let me run it. Python. And as I mentioned, because we are choosing the size, I just added basic use case here. So choose small or large. So let's first try to work with a small one. Okay. I didn't decided to close all warnings just to see what's happening. Okay, we loaded the model, we pre-processed our data set, we indexed it, and now we can open our app. Okay, let me put it here, and I will make it. It's still, I think it's still really small. Okay. So what we have here, we have our basic get results. We say, okay, go here to go to our route. And if it's okay, if a success, send us this message. So we send this message. And now only from the next one, how to test the post. Usually you will be using Postman or just curl it. It depends on your preferences. But the FAST API comes with a really good thing. It collaborates really easily with Swagger. So if I want to test the APIs, in this case, I just need to add docs. Voila, what we see here. So this is our visual search app. And then we get actually our methods that are available. So we have get, this is our read route, our PyData Amsterdam Festival rules message. And then this are two post methods that we described. One is predict image by category, and another one is just predict image. So first option, we send the category, and let's try it. So I think we can even make it a little bit bigger like this to make it more visible. So let's check first category. So first what you see an example value schema. Let's get back to it. So remember our schema. So this is that's inherited from Pydantic. And you say we can define the class of our body, the Cerebras model, and define that it should be a number and it should be an integer. Okay, let's check it. So if I say try it out, so now we see the schema. It's already prepared it for us to send a request. Let's say the category 15, and then say execute. Okay. So what we get, so that was our curl. We are sending the request to a model, predict by category, and this is response body. So this file is really, really huge if I scroll it down, because what it returns for now, for the sake of this demo, we ask it to return to show the region of interest, and we ask to return the masks. And actually, there is something uninteresting in this picture. It gives us it gives us true, and if there is nothing, it gives us false. So there are a lot of masks here. Then we have at the end of it, if I manage to scroll down, if not, I will go for the, okay. Yeah, it's still, so it looks like the category that we picked, that the target image and the original image doesn't have a lot of similarity. Oh, you see some true popping up and the masks. Okay. So that's what we have. And then what if I remember that I have the category numbers for the MS-COCO data set is from 1 to 80. And what if I want to put some, I don't know, some strange stuff here? So what if I put like, I don't know, something like this? Let's try to send. Okay, and it says unprocessable entity. Good. What if I send a number? Like 100. I get okay and the message. I say, so if category not in range, return the message. Please indicate a number in the range from 1 to 80. Definitely, you will not do this in production, but just for the sake of the demo to see how we can play with the FAST API and how we can play with Swagger, we are doing this. Okay. So we tried this part. Okay, now the most interesting thing. What if we try to predict the image? So we are taking the big image from the test set. This image was not seen by the model before. So we are taking this one, and then we say randomly initialize the target image and compare them and return the results to me. So in this case, because here with FastAPI allows us to define, to use OOP to define the classes that we're using. So we use an upload file. It just allows us to upload the image. So what do we need? It will be a string and binary formats. Let's try it out. Let's choose file. Okay, let's check data, Coco, and it's test. Yeah, what image to pick up? Any ideas? I don't know, something. Maybe something like this. Let's try. Execute. Remember that all of these predictions are running currently on the CPU. So we send the image. It was preprocessed, resized, then it was sent to the model and compared with the target. And this is actually the results that we get from it. Our regions of interest, the masks, and the rest. So this is really, really basic thing that you can do. There are much more that you can do with FastAPI. As I mentioned before, starting from define your input schema, you can use queries here. You can use a lot. Normally, it depends on the model, how you expect from the model to return predictions. Do you want to do it in batch size? This particular model is optimized for batch inference as well. So it can accept not only the one image, it can accept the list of images and can accept the list of target images. So we can even send more. Then normally when you do this, you want definitely to work with some database to save indexes or to save some necessary result there. So there are much more that can be here with a FastAPI. Highly recommend to go and investigate further. For now, I think I want to briefly also try another model. So it was the small one. Let's just really, really briefly check the big one, large. Okay, so it's loading checkpoints, it's starting, and loads into memory, loads annotation into memory. Yes, loading checkpoints. Great, let's start. Good. Once again, when we started, we are getting to this particular site. And then if we go to docs, we're here again. So let's just try image, try it out, choose file, anything we want. I know serverboard, for example. The large config, this much heavier. That's why the predictions take much more time. And right now, my PC is trying doing its best to run it. Okay. So we get the return. Okay. Finish the process. So let's get back to slides. And here in the slides, let's try for now to have the large model, just to see what's happening there. Okay, now we have the large config. Now we select checkpoints. And then we need to load the model, the biggest config for the model. Oh, really interesting. To equal. Okay. Oh, yes, we need to arrange the shapes because the shapes in this case, we need to pre-process the data. Okay. I got what's happened. Okay. Because the shapes doesn't match. Okay. Then we need to change that then. And if I go back, yeah, dimension both shapes not equal. Yeah, for the smallest one, and it takes the big one. Okay. So we can refresh it, or I think taking into account the time, I think we can go to the next steps for now. And then come back to check. So the home assignment in this case shares some ideas how to improve our MPI. So hints, think about security, how we can make it secureable, how we can use cache, how we can split it up for routers. Now we have one big file. It's not the best way to have. And what kind of validation schema we can add to spot all issues. So that's really it for the home assignment. And then I think we can go for the next part. So yeah, the known limitations and possible improvements of the model. So it's a really nice idea to build such kind of app around our API. But still we see that it's really computationally expensive, really one. And what we notice as well, that if we have the cluttered scenes, so a lot of objects, then our model really still performs, let's say, not really good. For some categories, it do its job really good. In the article, you can find the confusion matrices, and it's actually showing how the model performs. It also gives the hints of some overfitting, at least for training data. Then in our case, as I mentioned, we have the false positives that biased toward the most frequent training categories in the training sets. And you can assume what kind of these categories are, because almost a lot of pictures have people in it, or a lot of pictures have some round-shaped objects in it. So our model that was never seen, like don't have any ground truth and never seen like these categories before, but have seen this a lot of times while concentrating on detecting other objects and classifying other objects. So it still picks it up. And also what we noticed that if we are trying to do predictions on novel categories, then actually the performance of models really dropped. This is like the case with this pigeon. When you ask to show the pigeon, and it identifies the bird really good, but it also picks up the rest of the clutter. Sometimes it do weird things. For example, if you want to identify a bus and it finds a bus and then try to identify the stop lights of the bus. So there's still a large room for improvement. So the possible improvements, we can try to retrain this and change the architecture a little bit in a more lightweighted manner. The code base definitely requires a lot of refactoring. And what I mean by that, I mean the source base for both libraries, because it has a lot of hard-coded path. Then if we want to use this, because I just use this, let's say the model, I generate the model in inference mode and immediately, let's say, use it for prediction. It's well not the best way, because if you want to do it, you want to first like prune and quantize your neural network. And also what we can do, we can train on completely unseen novel data sets, because this is actually what you see in the live case scenarios. The client says we have a lot of data. When you start inspecting this data, it seems not. And it's really, really hard to do. So the home assignments, you can retrain this model on a new data set. Please share your results. I'm really curious to see it. I also only tried it for the client data set that unfortunately is not able to share. It's manufacturing data set. So with manufacturing data sets, it works even worse. Because there are not a lot of, let's say, not a lot of novel categories, but they're really specific one. So it still sometimes picks up really random stuff. So I should say that if you look at the classification, so it works okay. It can identify that this present, but when it comes to applying mask, it can do some really weird stuff. Then also please go try out the meta learning techniques, especially zero-shot learning, because imagine if you have some, let's say, text, and based on this text, or if you have images and based on the images, you can find something. So it's really, really cool. Also, what you can try to do, you can find a suitable model, like to build a basic meta search app. Let's say I want to input some a description like person sitting drinking coffee, and just look for the results. or you can, let's say, upload 2 or 3 images and say, give me, look for it and find me these images. So yeah, there's a lot of, this is really interesting format for me as well, because normally all workshops has a lot of hands-on stuff in it. So you can follow along, you can stop, you can ask questions. It's really weird to talk to your computer sitting in your room, really. And usually the workshops that I give is like 3 hours or more with more practical hands-on stuff. But for me, I say that this workshop is literally for beginners, just to understand how you can really fast go from the research paper code and just to try to build API around it and to see what you can take from it. So I completely skip all parts about how you can build, how you improve all the layers, what you can do. Yeah, and then as a bonus, I have a really nice checklist for modeling deployment. Please share it with your colleagues. I want to say that this 2 checklists, like modeling checklist and deployment checklist, it was taken from the Medium article of this person. There is a link to this article as well. So here we have like the basic stuff. You will take time to read it through. Yeah, I think that's it. Yeah, so in this case, I think I was too fast to finish it like 12 minutes earlier. So now, if you have any questions, please do. Oh, the same Mary's handbook incident. Okay, misclicked. So feel free. Sorry, once again, it was a little bit biased and it was a little bit cumbersome because I want to share as much as possible in the really short period of time. But the goal was just to show how it's, let's say, relatively easy to go from the research paper to find a way, some hacks around it to keep it working. This is the issue with a lot of research papers. There are really great ideas with a really cumbersome code implementation. Yeah, and usually from my own experience, I didn't mention or forget to mention that usually, so I prefer, if it's possible, to go without neural networks. So because sometimes you can just solve with easy things. If it's about neural networks, I have hands-on experience and production experience only with computer vision tasks. So everything regarding LLP is I'm still really curious. There are a lot of on the market that you can research, investigate, like Spacey and all of this stuff. So it's really cool. So far for me, the computer vision stuff, mostly for manufacturing companies, when you do quality checking, when you try to understand, or like records from even from processing records from security cameras, and to see what's happening on the plant level, on the like industrial level, what's happening there, or such things like identify the crops, or like all the computer vision related stuff. It's a really awesome field. I think it's a lot of things that can be improved as well, and it's really hard to do stuff because for us as a person, it's really easy. And actually, if we look at us as people, you can always say, okay, so we do actually the meta learning. So if you have seen something 2 or 3 times, it's enough for you to understand that, okay, this is maybe it's a dog. So it doesn't matter what kind of breed of the dog is. You know that it's a dog and you know it. But for the computer vision model, it's just a bunch of floats. That's it. And the magic, how you can go from floats to, let's say, the real classifier that will say, okay, this is this particular type of dog. This is this. Or, yeah, so I think there are a lot of possibilities and opportunities. The field evolves a lot as well. So a lot of libraries pops up. The still PyTorch TensorFlow is leading. And yeah, and a lot of pre-processing libraries. I see some companies right now building the like feature storages when you first like collect the most useful features and in order to save computational resources, you just don't recompute it again and again and again. So it's really cool, really nice, really interesting projects. And yeah, regarding the deployment, there are different options. And as I mentioned before, for example, I personally love to work with Seldon if I run the stuff in Kubernetes, because actually with Seldon, you get a YAML file where you specify the whole deployments pipeline, what should be there, like preprocessors, all the stuff. And then it do the magic. You don't even need to write any API, so it's do it for you. And it can do A/B testing. It can do multi-arm bandits. So a lot of stuff's already prepackaged. Also, right now, working on the machine learning ops platform that try to cover all the pipeline from the data ingestion, taking into account data governance, data lineage, that goes to the all steps what's happening with data, how they were pre-processed. Of course, using ML flow on the background to log all parameters, hyperparameters, metrics, binary artifacts, and then to decide what is the best option, then bring it to production, and then to see immediately like integrating with all necessary stuffs with CI/CD pipelines. So it's really wonderful to see what's happening. So yeah, once again, thank you so much. I see there's like 8 minutes, no questions, or it was really terrible that there is no questions, or it was too much in the really short period of time. We'll see. Anyway, I think we can be on Discord after. So I'm also curious to see what's happened with this content environment as well. I see one question. Yeah, the good questions. What happened to visualize IPNV in your repo? It was very last night. It was just transformed from visualize IPNB to the workshop slides. It was just merged. That was the original idea of it. That's actually what happened. I also want to investigate right now what's happening with the shapes for the large config. Just use workshop. So now it's like workshop slides instead, right? And once again, it's only inference part. So if you want to do some training, if you want to retrain this model, I have at the bottom of the README file, I have the links to original repos, to Siamese Mask R-CNN, to the Mask R-CNN. So just go there and check it, and it has different. So you can do transfer learning on different levels. You can start it just from the backbone from ResNet. They have the 3 options, 3 weights for the different ImageNet data sets without the interference with MSCOCO set category, or you can retrain it from, for example, from the middle. From what I see now, the small configuration has 160 AppFox with 1,000 images in each. Then the big one was like 320. And actually how they train, so first they train the heads, then they go to the, let's say, middle layers, you train the middle layers, and at the end you have the, they actually decrease the learning rates to, not decrease, they actually, how you say it, not split. Okay, so you make your learning rate 10 times slower. So for now, especially for novel categories, because of this a little bit overfitting on the MSCOCO, because of some of the categories that pops up really like people that are all over the place on the cluttered images, then for something it can perform well, for some not. So there are different options what to do with it. And also take into account if you want to play with Siamese Mask R-CNN, they have a little bit changed Mask R-CNN source code in it. So if you want just to play with Mask R-CNN, go to their repo. If you want to play with Siamese Mask R-CNN, then just follow the Siamese Mask R-CNN repo. And as I mentioned before, for people who use Windows, unfortunately, there are a lot of hard-coded stuff in this source code, and the paths are represented in the standard Unix format. So yeah, you need to actually dig into it, or just install VSL and run Ubuntu on Windows. That's what I'm doing right now for this presentation, and it will help you. Yeah, I think that's it. And the goal. Yeah, sorry.
Thank you very much. It was I'm not someone who does a lot of computer vision, and I found it very, very inspiring, very fun to see like what's possible and what you can do with it.
Yeah, but what I want to say that like for all people like who know Matthijs, so he is a person, he's standing behind the Scikit Lego library. So I think it's together with Vincent, right? So you can just like, it's all about open source. It's all about what we are giving back to the community. So please go check. And tomorrow we'll have this open the Panda sprints. Yeah. That is, I assume you can actually create the pull request and fix basic bugs or write documentation. So let's say what I want to say. So if you're a beginner, if you have never have any experience doing something for open source, start small. Start with basic tasks or documentation. That's, let's say, low-hanging fruits. And then you can, if you feel that you can do something more, then do it. Or for example, if you're working on the project and there is and you're reusing some open source components, you can always give back. For now, for example, for the last project I used to work with FB Profit, it was really cumbersome experience. The first time in my life when I came across the model that takes data frame as an input and returns data frame as output. So everything regarding using Spark, it's really terrible because you need to transfer to user-defined pandas data frames, and the whole process. So all gains that you can get from the, let's say, fast Spark processing, it will be just killed by this model to work with your data. So the whole model, it doesn't work in a distributed manner. So, and for this FB Profits, while working with MLflow and while working with Azure, so there are a lot of things that are not compatible. So in this case, if the customer allows me, I can always reuse this code and just give it back to the community with some improvements for FB Profit or some improvements for MLflow. So there are a lot of stuff happening around. So please do. And once again, don't forget this awesome library. Maybe it's like 2 minutes left. Maybe Matthijs can share a little bit about this library because it's awesome.
So for everyone who uses scikit-learn, you probably had at some point ran into something that you miss in scikit-learn. That also happened to me. That also happened to Vincent. That happened to a bunch of our colleagues and people we know. And at some point we decided, well, let's just put them all together and make a pip installable. So that means there's there's some models in there that take different losses into account. There's some models in there that try to remain fair with regards to some kind of protected attributes. There's cross validators. There's a ton of meta estimators that do stuff like sampling or fitting a model per group and trying to reweigh those in interesting ways. It's not really an overarching theme, except for things that are useful when you use scikit-learn. We're very open to contributors. We've had many people just pop up out of nowhere and say, hey, I think this would be a cool addition, or actually you built something that's broken, can I fix it? And we always love those. If you do make a pull request, I have a huge stack of stickers here somewhere. The logo is pretty good, as you can see. So give me a message and I'll send you a sticker.
Yeah, it's a really great one. And I just like pop it here. So yeah. It's here. It's Scikit Lego and it's awesome. Especially take a look as well on the pandas pipelines, because what I notice, a lot of people have no clue that it exists, and it's really cool concept, and it's really help you to clean up your code as well and to see what's happening in the whole pipeline, how it runs. But sorry, maybe I'm just biased once again towards machine learning engineering. That's why I'm thinking in the pipelines.
Pandas pipelines are probably my favorite part, and I'm still salty that the same thing doesn't work as well as Spark out of the box.
Yeah.
I think the transform method was released in Spark 3, but it doesn't take keyword arguments or it doesn't take var args and var quarks, so it's not the same. But yeah. Cool.
Okay, so I see that, it's time to conclude our session. So for people, please ask your questions. Please be as critical as possible and talk to me on Discord. I will be here with you for next hour, just to keep it working, to keep it flowing. Thank you so much.
Thank you all so much. And thank you all for attending as well. Hope to see you either in the lunch session or the talks later today again.
Great.
And thanks again, Alyona.
Yeah, thanks.
Bye-bye.
Bye.